All right, thank you very much. Welcome everyone to Decorators Demystified. There's my Twitter account and email address. Let's jump into it. My name is Mark Baggett. I am a pen testing and incident response consultant, also a senior instructor for the SANS Institute and the author of SEC 573. Here's a little bit of my background. I do have a master's degree of GSE number 15. I've got some experience with the Department of Defense for the last 10 or 11 years, and before that I was a CISO. Started out my career as a developer and then a systems administrator. So I've seen a wide variety of skills throughout the industry. My name, there's my geek creds, right? My name does appear in the source code for Metasploit a couple of times, even though I've never actually developed a module or that myself. As an industry, we do a really good job at giving credit to researchers and things like that who found techniques or tools, and so I appreciate that from the Metasploit developers who have included my name in the source code. So first of all, try this at home. I got a couple of links here that'll take you to a couple of gists on my GitHub that will walk you through following through these things. So there's two of them. One of them is in Markdown, which will let you click on links and actually execute the code as we go through it. This is going to be important because this is an advanced presentation. And then this other one here is strictly just code samples. So if you wanted to just grab a copy of the code and run it inside of a PyCharm or some other Python interpreter outside of running it using the web page, then you could use this second link. If you don't trust these links, with tiny URLs, you can always put preview in front of the URL, and it'll take you out there and show you where the URL is going to take you. But it's basically going to redirect you to here, to my GitHub page. A couple of decorator examples is the name of this gist that's out there. Two sections. This first section up here is the Python code directly, and then beneath that, you'll see the Markdown version of this, where you got links that you can click on and go follow along with me if you'd like to do that. Okay. If not, I'd encourage you to follow along with pausing the VM when you go back and watch this later. So as I said, this is an advanced presentation. I'm going to assume that you've already taken 573 and taken this class, or that you have obtained this knowledge somewhere else before coming to watch this presentation. Specifically, you're going to need to know how to create and use Python functions to follow along. You're also going to need to understand variable scope and the whole LEGB variable resolution, meaning that first functions look locally, then they look in the enclosing functions, and then they look globally, and then last they look inside of the built-ins modules to see what the values for those variables are. You have to understand argument packing. This is sometimes known as the args and kwargs. This is where you have the asterisk args and asterisk kw args inside of your function, and we pack up variables and then pass them on. Now, this presentation is much different than 573. 573 does not assume that you have any knowledge coming into the class. It assumes no knowledge and no experience, and then it drops you into a self-paced training environment where you can work through labs, and wherever you come in, I'm going to meet you where you are and then advance your skills. If you've never coded before, when you leave, I will have presented all of the material that you need to be able to go back to work and begin writing some basic Python scripts or modifying existing Python scripts. If you come in, you already know how to code. I'm gonna take you to the next level. We also have advanced programmers who come into the class who already know Python at the beginning of the class, and we're going to teach you to focus on building those skills so that, we're going to develop those skills so that you become an expert programmer and can develop information security specific tools. Okay, and we've got a couple of opportunities for you to take the class coming up. There is the SANS Pentest Hackfest Summit, which is November 12th, and the class is going to follow the summit from 14th through the 19th. We're also running 573 in Stockholm, Sweden, so that'll be coming up in November 16th, 26th, if you're interested in taking those classes there. So let's jump into this. So what are decorators? You probably have seen these things before if you've ever looked at Python code. They're frequently used in web application development or web application frameworks and things like that. So for example, this is a line of code that you might see in a Flask web application, where we have this @app.route and then some arguments that are after that. This is an example of a decorator. In this case, the app route is a function that is decorating this show maps function. Here's another example of a decorator here where we are using the property function to decorate the count function. And so a decorator is basically a wrapper for another function. So what we're going to do is we're going to take this show maps function and we're going to do some things before we execute the show map function and after, and those things are defined inside of this app route. There's two different examples of some decorators here. Here you see a decorator that doesn't have any arguments, so there's no parentheses after this with stuff inside of it, like there is up here for app route. And then we got a second example of one that has arguments. And the way that you implement these two different things is quite different. So we're going to first start out by looking at the simple example, which is an example of something like this, where we're going to create a function called property that's going to decorate other functions. In this case, property is decorating count. So when would you use decorators? Well, because it's a wrapper to another function, you're going to put things in there that you would do before and after executing other functions. So some examples of ways you might do that would be to time functions and see how long they execute. So we're going to, before we execute a function, record the current time and then execute the function. And then after the function executes, we will record the new time and we'll see the difference between those and figure out how long did it take for that function to run. Another example of a way that we might use a decorators is for setup to external connections. So if I needed to connect to a remote SSH server or connect to a remote web server and log into that web server with a certain amount of credentials and then do some stuff that's in a function and then log out of the function or log out of the web page, I might do that in a decorator, where in the setup, I establish the connection and log in, and then in the teardown, I just log out of that connection. And then I can wrap the code that is actually, I don't have to worry about what it is I'm going to do with those websites or how I'm going to get into the websites. I just write what it is that I want to do on the website, and then I decorate it with the connection and the teardown. Another common use of decorators is what is often referred to as memoization. Memoization is where, let's say that I had a function that had to calculate things or make connections to external websites. For example, I developed a tool called Domain Stats that you can use to interface with Whois servers and query statistics about domains and look these things up in your logs and tie it into SIM products. The call off to Whois takes a while. There's a delay that's in just built into interacting with things across the website. So I'll use some memoization where I'll first look in a cache to see, have I looked this item up before? And if I did, then I'm just going to pull it from the cache instead of making the call to the function. Now, what I could do is I could use that as a decorator. So in my setup, I could first check to see if the value that it's being passed to the function has already been calculated or already looked up and is already in my cache. And if it is, pull it from the cache. If it's not, then I'll allow the function to execute. And then in my teardown, or the thing I do after the function is executed, is I take the value that came back from it and I add it to my cache. So these are some examples of when we might see decorators being used. To understand how decorators work, we have to understand a couple of prerequisites. So let's talk about a couple of things that you need to understand. First, understand that a function is just an object and it can be referenced by a variable. And just to illustrate this, we can take the function print and we can assign the variable x to point to the function print. Now, because print is a function or it's an object, I can now use x to refer to that same function. So I could just call x, open parentheses, hello world, and it executes in the exact same way as if I had said print hello world. It just executes the code. Now, the local variables, the values, and the codes, everything is actually stored inside of this variable X. They're all stored in attributes that are associated with variable X. So here, I'm going to create a new function, and I'll call it new func. It takes in some arguments, it has some local variables, and then it just returns back a value. Now, all of the variables that are associated with this function, and even the code itself, are stored in attributes. So here, when I look inside of my interpreter, inside of the dunder code attribute at the co-variables, I look at dunder code co-constants, I can see the names of my variables and the names of the constants. And actually under dunder code co code, I can see the byte code that's associated with the program's execution. So when we call new func, everything that we need to know about that function is stored inside the variable new func. All right, so Python object or functions are just Python objects that are stored inside of a variable. And I can create functions that create new functions. So for example, here I've got a function called print in color. And what it does is it creates a new function. Now, this print in color function does two things. It's going to set the color of the screen to whatever color you tell it to set it to. And then it's just going to print whatever you print. Now, to really understand what's going on here, I'm going to pop over to my Python interactive shell here, go back over to my markdown, and I'm going to walk through some of these examples. Here's this first example where we set X to print. If I want to watch that execute, what I can actually do is I can click this, I can open it up, and this is going to take me to this visual Python tutor. And here I see the code over here on the left, and then I can see the output of the program over here, and I've got a forward and backwards button where I can execute the lines of the code one at a time and actually watch and see what's happening here. So with our first example, when I said X equals print, X now contains the function print. When I call X hello and I pass it some string things to print, it actually prints to the output. Right? I can call hello as though I'm calling the print function. All right, so let's take a look at what's happening here with print in color. So I'm going to open up my visual Python tutor here. And here's my print in color function already defined for me. And let's watch what happens when this thing executes. All right, so the first thing that happens is the definition occurs. So now I have this decorator or this new function, we'll call it a function factory, sitting out in memory and call. And now I'm about to call print in color and pass it in the argument red. So let's go ahead and do that and watch this thing execute. Print in color takes in the variable red, so red, color is set to red, and it then defines a function called colored print, and it returns that function. Now you'll notice that red, color is set to red, and it just creates a function and returns that function back. And now the variable red print is pointing to this new function that's been wrapped or generated by the print in color that will print things in color. I'm also going to create a function called print blueprint, which is going to call print in color and pass in blue, and it creates a function that is going to print things in blue for us. So now when I call red print, Mark was here, and I pass it in, Mark was here, it executes my function, it prints set the screen color to red, and then it prints whatever it was that I told it to print. When I call blueprint and I pass it, Mark was not here, well, it says setting screen color to blue, and then it prints whatever it is I told it to print, which in this case was Mark was not here, and that's it. So this print in color function generates new functions and executes them. Now, one question you might have if you understand how Python functions work, you'll remember that, well, what happens in the function stays in the function. And when a function executes, the variables that were in memory go away. So if I create a function called redPrint, when I call it, a function called blueprint, I call it, how is it that when redPrint runs and when redPrint executes and it prints set the color to red, how is it that this variable color here still has its value of red? Because this print function, here we called print and color executed, and it returned back this function. And print and color is done executing, which means this color variable that was associated with print and color has gone away. It's no longer in memory inside of Python. So how is it that when we call blueprint or red print and it prints the variable color here, that it actually knows the value that's associated with that color to be able to print the colors in red or the colors in blue? Well, those things are stored in what's called Python's closure. So just like the variables and bytecode that's associated with a function are stored in attributes of the variables that are associated with that function, closures are a special place that we have inside a function where it can store the values of any parent functions that have exited that the child function depends on. So if we look inside of red print, right, if we looked inside of its code, we can see the variable names, we can see the code constants, all of those normal things, but we can also look inside of the closure. And in the closure attribute of the red function, we can see the names of, or excuse me, the values that we have associated with variables. If I want to see the variable names, I can look inside of what's called the free vars. Free vars are the variables that the function depends on that were in parent functions that have exited out. So here I have a variable called closure that is set to red that is actually stored inside of the red print variable or function, which means I can execute it even though its parent function here, print and color, is no longer in memory. So the function remembers the parent function variables when it exits. So just to recap, Pythons are objects, or functions are objects that are stored inside of variables. And those variables have a closure attribute, which stores any variable values from exited functions that function depends on. And functions can create new functions. All right, so with that, if we understand those concepts, then we can begin to talk about decorators. Decorators are functions that create new functions that wrap other functions. So I know I said function 3 times there, which can make it a little bit confusing. Let me say it another way. A decorator is a way that you can wrap some function with other code to make it do things before and after it executes. Now, your decorator functions always take exactly one required argument. So you're going to create a function that takes exactly one argument in, and that argument is going to be the function that you want to decorate. And then your function is going to do some stuff. It's going to call the other function, the original function, and then it's going to do some more stuff, right? Now, you don't have to do stuff before or do stuff after, but you have the opportunity to do that with your decorators. So, and it's going to return back a new decorated function. So let's take a look at this in an example of a working decorator. So here I create a decorator. My decorator is called wrap function with prints. What I want to do is I want to be able to take a function like say hi that I have here, and I want to wrap it with print statements so that it will, when I call it, I want it to print I'm about to call, and then the name of the function it's about to call. I want it to then call the function, and then I want it to just print the word called so that I get some print statements that tells me, all right, I'm about to call this function. Here you can see the output of what it's going to do. I'm about to call a function, and then it'll call the function and let it execute, and then it will then just print the word called. So I want those 3 steps to occur. So I'm going to create a wrapper. Here I'm going to create a function, wrap function with prints. And this is going to take in as its one argument the function that I want to decorate. So I'm going to call this function to call, whatever I pass in. This decorator function creates a new function. And the new function does 3 things. It does whatever stuff I want to do before I call the function. It calls the function, and then it does whatever stuff I want to do after the function. Those three things are what happens inside of the function that you create with this decorator. All right, so I've got this decorator function and I want to decorate say hi. So I create a function called say hi that just prints say hi to the screen. If I just call say hi, it prints say hi. So now let's decorate say hi. Now, the way I'm going to do that is I'm going to call wrap functions with prints, and I'm going to pass say hi into wrap functions with prints. So my function to call is going to be set to the function say hi. It's going to create a new function that prints a statement, that calls say hi, and then prints called, and just returns back whatever value I got back from the function that I called. So now when I execute function X, it prints about to call, it prints the output of say hi, or it executes say hi, and then it prints called. To watch this thing execute inside of our Visual Python tutor, let's go back over here and I will click on this link. So here's our wrap functions with print. It generates a function or say hi. Let's just watch this thing execute as we step through it in Python. First thing that happens is it creates wrap function with prints in memory. Then we're going to create our function say hi in memory. Now if I call say hi, you'll see the output. It just prints hi to the screen, and that's all it does. So now I'm going to wrap say hi with prints, and I'm going to create a new function called X that wraps say hi with prints. So we call wrap with prints, and I pass in as its input say hi. This generates the function called newfunc, and it returns it back. So now X, my variable X, contains, you can see X points to this function called newfunc that was generated by my wrap with function prints. Okay. Now let's execute X. Okay. When I execute X, it comes up here and it begins executing new function. Now in this case, there are no arguments for new function, so args and kwargs are blank, but we're then going to print about to call say hi. We then call the function say hi, which prints hi to the screen. And then we come back and we print called, and then it's done. Okay. So that worked with say hi, but in this case, say hi didn't take in any arguments. It works exactly the same when you wrap a function like add that does take in arguments. So here I have a function called add. It takes in two numbers, and it just prints number 1 plus number 2 is equal to num1 plus num2. So if I wrap that by calling X, it's going to do the same thing, and you'll see that it works the same way. Let's just watch this in the Visual Python tutor as we create add and then wrap it. So here I've got my function called add. Let's wrap add with print statements. I'm going to create a new function called X that is wrapping add with print statements. Goes up, my function to call is set to add, creates this new function, returns the new function. Now notice here that wraps with prints is exiting, right? So this wraps with prints function is not going to be in memory anymore, but this function to call, which is pointing to add, is going to actually be preserved inside of the closure of variable X here. So we return back our new function. Okay. Now in the closure for X, function call is pointed to add, and we're about to call and execute our function X. All right, so we're executing our add function. Notice this time args and kwargs are set to 10 and 35, the values that we are passing in to new function. It's going to then print about to call the function. It then calls whatever is stored in the variable function to call, which in this case, function to call is set to point to the function add. And it's going to pass in our args and kwargs, which are the arguments that have been passed into our function. Okay, so it's going to call add. It's going to add those things together. Print 10 plus 35 is equal to 45. And go back to our decorator and continue executing. It's going to print called to the screen. And that's how that works. Now, in this case, I wrap these things inside of a variable called x. Both of these times I called my function factory and I told it to wrap this function called add, and I wanted to create a new function called x. Okay, but typically decorators will usually, instead of doing that, overwrite the original function. So what I would probably do in creating decorators is if I wanted to decorate, say, hi with these print statements, what I would do is I would overwrite the original variable that stored the function, say hi, with the decorated version of say hi. So instead of saying x equals wrap the function say hi, I'd say hi equals wrap the function say hi. And so now when I call say hi, it's going to print, I'm about to call say hi. It calls hi, and then it prints that I've called say hi. So I've changed the functionality here. Even though this is what my function definition originally looked like, this overwrites the original function definition with this new wrapped say hi. This is typically how you do it when you're doing Python programs. But Python provides us with a shortcut, basically a syntax shortcut to override original functions with new values. That is what we call syntactical sugar, right? So it's just a different way of doing the exact same thing. So these two screens that you see here do the exact same thing. Over here on the left, we see what we did on the previous slide. We create this function called say hi, and then we're going to overwrite the say hi function with the wrapped version of say hi. And we can see that now say hi is decorated with our two print statements. Another way that I could do these two lines here is I could do this. If I just put @wraps function with prints in front of this say hi function, then this does this. What it does is it takes this function name that you have here and the function name here, and it puts it before an equal sign. So it's going to say, that's equivalent to saying say hi equals, it's going to take this thing, whatever you have here after the @ symbol, wrap function with prints, and it puts it there. And then it takes this function name and it puts it at the end here. So this syntactically does the same thing as this line here, where, let me change my color. Sorry, I apologize in advance to the colorblind in there. I should have changed this to blue to begin with. So this line here does the same thing as this line at the end, which overwrites the original say hi function with the decorated version of say hi. Okay. Now, once you've got that decorator, it makes it very easy to wrap print functions around lots of functions. So here I can just go through my code. I create the decorator once, and then I can wrap the say hi function, and I can wrap the say bye function, and I can wrap the adds function, and I can wrap the anything function. So once you've created the decorator, you can simply wrap this and simply wrap each of the functions that you want with some code. Makes it very easy when you decide that you want to change doing things before and after all of these functions. I just go back into my wrap functions with prints decorator and change it, and then I've instantly changed what I'm doing before and after all of these different function calls. Okay, so let's actually watch this happen one more time over here. So over here, if I overwrite the say hi function with wraps functions with say hi, okay, then I'm going to create my wrap function, return a function back, and then I overwrote the original say hi function with this new decorated say hi function. So now anytime I call say hi, it will print about to call say hi. It says hi, and now it calls called. So notice this call to say hi didn't just go up here and execute this function, it executed my decorated functions because I overwrote the original say hi variable with this decorated version of the say hi variable, which I can also do with the syntactical sugar. Okay, so once again, if I put an @ symbol, @print, above a function definition, what it does is it takes this function here, puts it on the right-hand side of an equal sign. It then takes whatever you have after the @ symbol, puts that on the right-hand side of the equal sign, and then puts open parentheses, and this function goes in here as well. So that's what this syntactical sugar does when you wrap these functions. So what's going on when we have these more complex decorators like @approute/get? This is an example of a decorator that you might see inside of a Flask application. Well, in this case, it's doing the exact same thing that we did with the other syntactical sugar. It takes this name of this function and it puts it on the right-hand side of the equal sign. It takes whatever is after this @ symbol, which in this case is this whole thing, including these arguments, and it puts that after the equal sign. Then it adds to the end of it an open parentheses and a close parentheses with the name of this function being passed inside of that function. So this syntactical sugar here, wrapping prints with inputs, is once again equivalent to this line over here, where we call wraps with inputs, pass our arguments, and then we call another function here and pass in say hi. So we've got two function calls that are happening here. Now, when we do this more complex decorator, we've got this first function call, and we have this second function call. So now, if we're going to create a decorator that takes arguments, we have to add another function into our process. We actually have to have 3 functions inside of our decorating process. So let's take a look at what this would take to create a more complex decorator, but first let's look at it without using the syntactical sugar. So I'm going to create this function called decorate with arguments, and it's going to take in some variables, item 1 and item 2. And then inside of that, we have the exact same thing that we did for the less complicated decorators that don't take in arguments. This is just a decorator function. It has a decorator factory. It takes in a function that we're going to call. It then creates this function that we're calling. It's going to do the print statements before and after, and it's going to call my function and execute it. Okay, so it does our print statements, prints it, and then prints called afterwards. So it's the exact same thing we looked at before, but now we've got another level of functions that are wrapping it up. And the whole purpose of this outer function here is to collect up these variables, item 1 and item 2, and hold them inside of the closure that is associated with the function that's being this decorator factory function. All right, so what does it look like when we call these? So now I've got my decorator with args. I'm going to call it. So I've got my function say that can say things, and I'm going to say call the function decorator with args and pass in these 2 values. So SEC 573 is going to be assigned to the variable items. Rocks is going to be assigned to the variable items 2. This is then going to generate this function here with those values inside of their memory. And then it's going to call say. It's going to call this decorated function, passing in say as its argument. Say is then going to be passed a function to call, and it's going to execute just as it did before. Now this is many levels of redirection that are happening here. So let's watch this thing execute inside of this Visual Python tutor, see if we can understand what's going on. So I'm going to come down here in my notes. We're going to find where we have decorators with arguments. I'm going to right click on this, open it in a new tab, and bring it up so we can watch this thing execute. All right, so here I've got a decorator with arguments. It's taking in items 1 and items 2. It's going to create my decorated, it's going to create a decorator factory with these values stored in their closure. And then it's going to create a decorated function with wrapf. So let's do this. We create our function, we create say hi. We then call decorated with args and we pass in 573 rocks. Decorator with args sets the variables item 1 and item 2 to the arguments we passed in our decorator. We then create the decorator function, or our decorator factory, which has SEC 573 and rocks inside of its closure. It exits. Okay. Now, notice that it immediately called the decorator function. The reason it called the decorator function is because here we call the decorator, which sets items 1 and 2, but the very next thing that happens is it does this set of open parentheses, which calls the function that we just returned, called decorator factory, and passes in say as its function to call. So let's watch this thing execute. Here you can see function to call points to say. And what this is going to do, we're just going to print a variable just to show you this decorator function has access to SEC 573 and rocks inside of its closure. So those variables, even though this function exited, it still has access to those two variables inside of its closure. And it's going to do its normal decorator job, which is to create a function that wraps some other function. In this case, it's wrapping say. So we create our function and return it. So now X points to a decorated version of say that also has these variables item 1 and item 2 stored inside of their closure. So now I can call X, which is my decorated say, just tell it, all right, I want you to say, and it will begin executing. It prints about to call, shows me that all my variables are set. It calls, say hi, prints to the screen, comes back, prints called, and that returns. Now, rather than saying X equals decorator with arguments, most likely this is the syntax you're going to see. This is what we usually, this is the way we really code this up in Python, is if I wanted to decorate the function say hi, and I wanted to wrap it with print functions and initialize these variables to be held in closure, then I would do something like this. I would say, call my decorator with args, hold these values inside the closure of say hi, and decorate say hi with prints. And this does the exact same thing that we saw before. Okay. Executing, and it calls my functions and executes them. Okay, so lots of things going on there. So just remember, from a syntactical standpoint, what we're doing when we have a function with args, this first function call that happens here is that we call the decorator with args, we pass in these two values, and these values are just stored inside the closure of the decorator that we eventually execute. We then pass the function that we want to decorate into this thing, which just creates a normal one-level decorator, or this is the same, at this point, this becomes the same as a decorator that had no arguments. And this is syntactically the same as doing it this way, which is typically how we do this inside of a Python function such as Flask. All right, so let's look at this in execution. So let's actually do a practical example of this. So here I want to create a decorator that I can use to test how long functions take to execute. So I'm going to create a function called time this. And this is going to be a one-level decorator. I'm not going to use arguments just to keep it simple. I'm going to create a function called time this. It's going to take in a function. And it's going to decorate whatever function you pass in it with the following code. It's going to record the start time of the function into a variable called start time. It's then going to execute the function that you pass it and then pass on whatever arguments you've passed to the function and then get the return value that comes back from the function. After the function executes, it's then going to record the elapsed time. It's going to look at the new date and time, and it's going to look at what is the current time, subtract the current time from the start time, and that's going to be my elapsed time. It's then going to print that the function name took this number of seconds to print or to execute, and then it's going to return back from the function. It'll return the return value of whatever function you called back to the thing that called it. This will create my wrapper and execute. So I need a function that I can time. So let's create a generic function called execute command or exec command that takes in a command. Okay, this function here will take in a command, store it in the variable CMD. It'll then call subprocess p open to execute the command and pull the output of that command into the variables output and error, and then return the command. All right, so in doing this, because I've used the syntactical sugar in creating my function exec command, even though I only have 2 lines in here, this also, because of this decorator, has all of the code that's necessary to actually time it. So when I call exec command and I tell it to execute the command ls minus la, it tells me that the function exec command took this number of seconds to execute. You can see that this makes it very readable from a Python standpoint. Imagine how ugly this exec command function would look like if I also had to incorporate all of this decorator functionality into that code with it. So by creating that decorator once, I can then go through and add this time this decorator to lots of functions within my code to allow it to time it. Well, let's run a couple of different things through this exec command. You can see that an ls minus la of the root directory executes pretty quickly. An ls minus lar telling it to recursively go through the entire file system, well, that takes considerably longer than the first one. And if I do a ping count 4 times to sans.org, well, that took 3 seconds because there's about a 1 second delay between each of the pings. So that shows us the amount of time that we want. And this does still returns back the results of exec command, which we can hold in variable results. If I look inside the contents of the variable results3, here I can see the first couple of lines of the ping packets or the ping command's response coming back inside of that. Okay, so I can use this time it function to time various things once I've defined that decorator inside my code. But something happens when you decorate functions, right? So I created that exec command, and now the help that's associated with my exec command doesn't work anymore, right? In here, inside of my exec command, I did create a help string that says the exec command runs a command and it captures the output. This is what's known as the doc string in Python. So my doc string, which the help function uses, should tell me when I ask for help on exec command, this function is designed to run a command and capture the output. But it doesn't, right? When I look at the name of the exec command function, before wrapped it was exec command. And when I look at the help string associated with my function, it was, well, this runs a command to capture the output. But after I've wrapped it, when I look at the name of the function, the name of my exec command function is no longer exec command. It's now the name of the wrapper function, okay, which was here, right? It now took that name. And this doc string, it calculates runtime, is now the doc string that's associated with my wrapped function. So my wrapper, my decorator, time this is working just fine. but it's stomping on the help functions and the name of the function for my exec command function. It replaced those values with the functions of the decorator that I generated. Well, we can fix this actually with another decorator. There's a special decorator called atwraps, and it's a decorator's decorator. So if inside of your decorators, you add this one line, you import functools, and then in functools, you say functools.wraps, this function. What this decorator does is it says, all right, after I've created this wrapper function, I want you to copy the original help docs, or the doc string, and function name, and some other attributes. There's more attributes than just those two, that it'll copy from the original function that you've passed in there and put those back on your wrapped function. So now when I do this, it's going to preserve the help strings and documents that are associated with that original function. So that's what's going on behind the scenes. So the next time you're looking at a Flask application and you see a command that looks like this, @wraps route, this thing is wrapping a function called showmap. What is this doing? Well, what this is doing is it is overwriting the showmaps function, this original showmaps function as defined here on the screen, with a new version of showmaps. And this new version of showmaps is going to have these attributes predefined in memory for some code that's going to execute in the setup of showmaps or in the exit of showmaps. That's what this decorator is doing. This property function on this code, right? This one doesn't take in any arguments. So what this is going to do is going to overwrite the original count function as we see it here with some pre-execution code and some post-execution code. Now, if we want to know what the pre and post-execution code is, we have to go and look inside of the property attribute of what those are. So while these little commands, these little @wrapper commands, look, they take up so little real estate in the programs, they're really doing a lot behind the scenes, which is really the power of decorators. With just adding a couple of lines of code to our Python programs, a whole lot is happening behind the scenes. They're a little complex in understanding how they work, but once you understand how it takes in a function, it does stuff before and after that function, and you can also use another nested function to store your closures. You can begin creating decorators that'll simplify the look of your code, right? It'll be much easier to read, and it'll give you the ability to take these decorators, write them once, and then wrap them around many other things inside of your code. And that's decorators and how they work. We have about 10 minutes left for questions, and I am hoping that you have many.
Hey, Mark, while I'm waiting for the questions to come in, I have a few of my own. Is there a place online where you can get examples or additional tutorials on decorators?
I am sure that there are. I did not put together a list of references for them. Actually, last night, I did this last night. Let's keep my annotation. I went out there and to try and find my own presentation link so I could register for it. I Googled decorators demystified, and yeah, I'm not the first one to. So that title has been used a couple of different times, and I was like, oh, somebody already wrote this function, this presentation out here called Decorators Demystified, and I started looking through this presentation. This one is actually pretty good. So there are several resources out there. I'm sure there's even some that have titles other than Decorators Demystified, but yes.
So Mark, during that explanation, we got a ton of questions. So the first one I'm going to start with is, Mark, I'm very interested in learning how to parse data from third-party mobile applications with Python. Will Sec573 teach me how to do this? From Lance.
All right. The question is to parse. So day 3 of 573 is all about parsing different types of data structures to be able to pull in information. So that we talk about parsing log data, parsing any type of text formats or reading files that you want to parse that information. Go through and then pulling out the valuable pieces of information using regular expressions, and then putting it into a consumable format where you can do some analysis on it. That's day 3. On day 4, we focus on forensics artifacts, which is similar in that if you think about it, a forensics analyst and a log analyst at some level are doing the same thing. But in one sense, the data analyst is analyzing text information or information that's stored inside of, say, a database or perhaps registries and things like that. In forensics, we're often dealing with just the exact same processes, but we're dealing with binary data, right? I've got an image from a hard drive or image from memory that is not as easily parsed. So we look at how to parse out those binary data to get the information from things like that. So day 3 or day 4 is forensics, where we talk about parsing out information and using information that is stored inside of binary formats. So regardless of whether or not the information you're looking at is in text or binary, I feel confident in saying yes, 573 is going to give you the ability to read through that information, extract the information, and do analysis on it.
All right. Thanks, Mark. Next question from Nadine. Can decorators be used with asynchronous code?
Can decorators be used with asynchronous code? Yes, absolutely.
Roger asked, could you demonstrate the @property decorator, please?
Can I demonstrate the @property decorator? Sure. I don't know how interesting or how exciting this demonstration will be, but I'll do it. So let's say that I developed a class, class that is, I don't know, a number. And in here, I've got a function called def get value. Okay. Typing is so hard. And in here, I say it just returns the number 5. We're just going to keep it real simple because, well, there's not a whole lot of time here. Now, down here, I'm going to say x is equal to a number. Now, this creates the variable x, and if I wanted to get the value associated with it, I would have to say x dot get value and execute it as a method because it's a method on the class. So here, let's just walk through it. This creates my function. This is going to create an x object, and then x dot get value. So let's create these as proper functions inside of a method here. All right, so we get our x value. We call x dot get value and returns the value 5 back to us. Now in this case, because get value is a method, I had to say x dot get value and put parentheses in there. One thing that the @property method would do is if I put @property here, this will make it so this method no longer appears to be a method inside of the class. It now appears to be an actual property. So when I try and do a get value by calling it a method, well, in this case, the visual interpreter, oh, okay, there it goes. It says the int object is not callable, right? It's now an error to try and treat get value as a method. You now need to treat it as a property associated with the object. So this function, to get the value, you now call get value. It actually executes the function, but it treats it as though it was a property of x as opposed to a method associated with x. Now, get property does several things. This actually does give you back additional decorators where you can set values and you can get values, you can set values, and you can check the values with additional methods that you get back from this thing.
Thanks, Mark. Rachel asked, could you give an example where the decorator variables are actually used by the wrapped functions?
Where the decorator variables are actually used by the rep functions. Yeah, so let's see, this last example here with atwraps, right? So within Flask applications, here, when we set these variables, this is actually telling, you're creating a web application that says, all right, I want you to listen in any request that comes into the root of the web page that is a get method. I want you to execute my showmap function. So this atwraps decorator within a Flask application takes care of all of the web, the network routing. So when a web page, when a web client makes a request to your Flask router, this registers this root directory structure and a get request with this showmap function. So in creating a Flask application, I don't have to wonder or worry about, you know, how does this web request get to my function? It just shows up in my function, and this app router is doing it. So these variables here are set by it and being used by the Flask application.
Okay. I have 2 requests from the people listening. If you could please either 1, comment if you enjoyed today's webcast and if there's things that you would continue to like to learn. And 2, if you have suggestions for future Python webcasts, let us know so that way Mark and I can brainstorm and put those together for a future webcast. Mark, probably the final question today, is there a way to make the wrappers conditional like C++ precompiler? For example, to turn on timing in a dev test run or off for usual runs?
There is, but what you would end up doing, right, is you go into your, so let me see if I can very quickly pull up. So for example, in my wrapper here, what I might do is in my wrapper here, in my non-production runs, right, I could just come in here and just put a return, right? And that way, this function actually does, well, actually, no, that wouldn't work. You just return func, right? And that would do nothing but return your function back to it, causing it to, oh, let's see, would that be? All right, so the answer to your question is, I don't think there is a precompiler built-in thing that can turn off and on decorators, but you could add some code to your decorators to make it do nothing in there. That way you wouldn't have to go through and remove the decorators from each of your functions. But I'm not aware of a conditional precompiler type of thing that you can just add to the top of your code to enable or disable the decorators. You would have to actually put some code into the decorator itself, as far as I know. So let me make one last comment with our minute that we have left, and that is this was a very complex subject. So decorators are one of the more difficult things to understand within Python. And we only had an hour to cover a very complex subject. So, and I assumed you had some prerequisites. Please do, let me bring back up my email address. Do not hesitate to send me emails with questions. I will learn from the questions that you send me, you know, how to better present a very complex subject in like decorators in an hour. So if there are things that you didn't understand, if there's elements of this, it might take watching the webcast a couple of times depending upon your skill level. If you're brand new to Python, wow, thanks for sticking with me for an entire hour. Really, this is a webcast you'll want to come back and watch after coming and spending a week with me on for 573. The 573 alumni who are out there, please do send me your feedback. Let me know what questions you have, and I'm happy to answer them.
Awesome, Mark. Thank you so much for your presentation. I'm going to turn it back over to Carol to end this for today.
All right. Well, thank you so much, Mark, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.